Hey nerds! I don't know about you, but I sometimes buy strange stuff. I mean, who needs a heart rate or oximeter sensor in his life? I certainly don't. Yet I was intrigued by this little chip over here while surfing the internet. The little PCB you see over here is designed by DFRobot, and it's of course buyable at the store. But this is in fact a MAX30102, a heart rate and oximeter sensor. On the backside of the PCB, you see some voltage regulators, some capacitors, some resistors to get all the voltages in the right place. I think this thing runs on 1.8 volts, and there needs to be some converter over here because we will power it with 3.3 volts. And of course, since it's an I2C device, of course we go for SCL and SDA. No serial thing out here. No. Of course, I didn't want to stare at the serial monitor every time I wanted to use the thing. So I needed something here that has a display on it and maybe a little CPU. So I came up with this one. One of my favorite CPUs, the ESP8266, and a little 0.91-inch OLED display is all I need. I can put all the information I need onto this little display and I'm done. Sounds easy, right? Right? Okay, follow me down the rabbit hole. By the way, if you hear someone singing in the background, this is a really drunken Spanish woman somewhere outside and I have no clue what she's singing about. Just for your information. And to spoiler the fun, yeah, it works. But believe me, this was some way to go. All right, what do we have here? The little controller board is in the upper corner. The little blue blinking LED has nothing to do with the software. This is simply the charge circuit because this thing can be powered by a LiPo battery. And there's no way in software to disable this. So sorry for that. Below that you see the little oximeter and pulse meter, and the little red LED is there to shine through your skin and to give the sensor a way to see your pulse there. If you're interested, please check the datasheet how this works in detail. I never did this. I simply want it to work. And to do a proof of concept, let me see if I'm not dead yet. Looks like I'm somewhat nervous while I'm recording here, but at least my oxy level is fine. This is the 90-something% over there. And you see, of course, my pulse rate, and looks like I'm not dead yet. So how does all this fit together? Well, let's take a peek under the PCB. Yeah, there's not much to write home about here. SCL and SDA is the green and the gray wire, and red, of course, is 3.3 volt, and black is 0 volts. First thing nobody tells you about. See the little reset pin on the left side, downward, second pin from the bottom? Yeah, this reset pin is normally floating. But if you have bigger fingers like me, and you touch this reset pin, you can actually pull this down to 0, so it resets the whole shebang. If you want to build this thing, just use a little resistor between VCC 3.3 volts and the reset pin. I used 10K here. This is 10K. I think it's 10K. So this is on a defined potential, not floating. Floating is bad if fingers are involved. Next thing I thought, okay, the little CPU only has a display and the sensor. So this should be pretty easy because I2C, addressable bus. So 2 wires and I'm done. Well, look at this. So I thought, this is going to be easy. The little ESP8266 doesn't see much. It has a display and it has the sensor. This is all it needs. And yeah, then I started to look at the pinout, and strange things are happening here. Normally, SCL and SDA is on pin 5 and pin 4. As you can see here, pin 5 and pin 4 are not used at SCL, SDA. This is something different over there. They probably use this over here. So OLED SDA should be on TX1, GPIO 2. This is really strange because this is normally a blinking LED. And GPIO 14 is a part of the SPI I'd normally use. And it got stranger after I tried to use the pins that are described in here. They simply don't work. but from here on, it's easier to look into the code. Let's get over there. All right, as usual, you find the whole project here as a download in the video description. This is a complete download, including the 1.8.19 IDE and all the libraries we used and all the files we used and stuff. So you simply unpack the download somewhere on your hard drive and start it from there. It works out of the box. First thing I try to do over here is draw a pin out here just by looking at the silk screen, and this was a strange experience, I tell you. From the silk screen, I have 2 times D2. I have no clue what this means. RxTx, this is fine, but I don't know what B1, RC1Z means. I simply don't. And believe me, I didn't try to use it. When in doubt, trial and error is your friend. Well, so I figured out that the display is connected on D2, D5, and D4. Why can I use D2, D5, and D4? Because the IDE is set to a Node MCU 1.0 module, and there I have the D1, D2, the Arduino speech digital pins. So the display works with this setting, and you can tell by the library over here. This is UHG2 library. This is a generic library for all these little OLED displays out there. And this is a really neat one because you simply tell it, this is the controller over here, this is the pixel resolution, and from there on, you simply feed it with that, and it works. You don't have to learn a new library for every display you get in your hands on. This is a really great thing because once learned, you can reuse it. While I'm on it with libraries, let's have a look at the sensor over here. And DFRobot supplies us with a library over here. So it's a no-brainer. This is simple because we simply use the supplied library from them and use this with the Oximeter thing. Let's have a look how the software over here works. Of course, we have to include wire. This is the standard for that. I use a little struct over here that I called sensor data and put in the O2 and the heartbeat, and it measures the temperature. So it's everything in this little structure because this is easier to handle for me. Of course, the hardware is separated into different H files. So we have sensor H, images H, we need this for the display, and display H. Setup is as boring as it gets. We initialize the serial port over here. This is the little smart debug thing I was talking about in the last video. I probably should start making a video about this because this is getting out of hand here. You probably want to know how this works and what it does. For the time being, this initializes the serial interface with 115-200 bouts, and this has a short delay because ESP8266 are too fast. You can't get the first messages over here if you don't delay it over here. If you want to get rid of the serial port and all the delay messages over here, you simply uncomment the little smart debug over here. Now you don't have any debug outputs, no serial output anymore. This is a way to deactivate all the debug output. I activate it now. So from here on, this is easy. You go in a display, then we draw a logo, and then we initialize the sensor. Sounds pretty easy, sounds pretty simple. I hate a delay in the loop. Well, we don't have anything else to do because the sensor needs 4 seconds to get its data ready. So I call the sensor get data every 4 seconds and change, update the structure in there, and simply display it. Well, nothing more to do. We don't have Wi-Fi on this here. We simply go for a loop that repeats every 4 seconds. That's all. The thing over here doesn't need anything more. Let me show you the logo, and maybe I should do a little how it's done, because that could be interesting for some people to get a bitmap file onto your OLED display. Let me show you. This is the logo. So this is simply a text, and it's displayed while we wait the first 4 seconds. While there's no input, of course, we display the "you dead yet?" And if I put my finger on there now, after 4 seconds, it would display my pulse rate, my oxygen level in the blood, and my temperature. But we saw this already, so I don't have to do this again. Yeah. So how do we get the logo onto the screen? Well, the function for this is draw logo, and it's in display. So let's have a look at this. Please ignore the wire begin over here. I come to this in a moment. U8G2 writes everything into a buffer, and from there on, when you're done with writing, it's transferred to the screen. So what we do here is we clear the buffer, then we draw an XBM. XBM, what could that be? It's probably a bitmap file, and it is. And after we draw this, we simply send the buffer to the screen, and this is done. And there's a neat thing over here. While millis are less than 2000, we simply wait over here. Millis start at 0, so the first 2000 milliseconds, we simply stay over here after we've drawn the logo. This is an easy way to get the start animation done. Well, thinking about this, I probably won't need this because I have 4 seconds until I have my first data, so I'll simply can delete it over here and save this again. Well, updating while showing you the stuff. Neat. So over here you see our image. It's images logo. So let's have a look in the image H. And yeah, there is a long char array. And it's simply called logo. That's all. So in here is a little title screen we saw over there. It's coded in here. And if you think now, well, that's sat down and typed all the numbers over there into this machine because he can do all this stuff in his head. No, I can't. But there are tools to do this. And let me show you a really easy way to do this. Back in the magical world of PhotoPea, not Photoshop, this is an online image editor. It's very much like Photoshop, so I'm really at home over here. And if you look at this, you can open even a PSD file, a Photoshop file in here. You can open all these files here. So they did a really great job. If you don't want to spend some money for a Photoshop alternative or for Affinity, this is a nice free alternative for this. So in here, I'll open a new file and I set it to, what did I had there? 128 by 32 pixels. There's my little image, and you can see if I activate the rulers, that is 128 by 32. So let me type something over here. And of course it's hello world. What else would I type? Come on. So I have a black and white image file over here. That is hello world, and it's the right size. So now I can save my little file, and if I go to File and go Save More, and no, this is not right, Export, and there's a More button over here because I want to have a BMP over here. So let's go for BMP and save this. Hello world, this is fine, the size is fine, and I'm fine with that. And save, and I drop it simply in my little project over here. I don't give it a file name, so because this will be the only file, the only BMP in there. So I'll save this over here, and I'm done with the editor. Of course, you can do way more over here. You can draw stuff because it's a graphics program. Everything you draw in here can be doable. So be creative, and I'll see you. Oh, wait. This is great, Scott. Let me continue with the thing over here. Next thing I'm going to need is ffmpeg. What's ffmpeg, you ask? It's a photo and video editor, and it doesn't have a GUI. It simply runs on a command line. Command lines that can get half a meter in length and are horrible to read. But believe me, this is the easiest way to do this, and you're going to use ffmpeg just for a really simple application. Let me download it. Gran Canaria has 92% of fiberglass internet. The only place it doesn't have fiberglass is over here. This is taking ages. I can't believe it, we're done. If you have to choose between from a master list, blah and a shared one, in the not shared zip, all the EXIF files are compiled so that it can be standalones. And if you have the shared one, you need some DLLs around there. So normally don't go for the shared one, go for the not shared one. All right, back to the files. Okay, here I have my download with the latest files here. Let me open this, and let me open this, and let me go into bin. And from there on, I only need ffmpeg exe. I don't need the rest. Simply extract it somewhere over here. So now we can get rid of the zip file. We don't need this anymore. So now we need a command line. So Windows run cmd. And let me get to the current folder over here. Copy cd, go there. I should tell her that she's on D, and there we are. So the only command line you have to remember is this one, ffmpeg. So this is tab to complete this, -E for input. And there you need the new project. And I'm going to rename this because I don't want to have a space in my file name. So this will become one something. So ffmpeg -I, dropping this over here, xpm. And as an output, I want to have this one, xbm. This is a file format. This is a graphics format. So let's convert this. Ignore all you see there on the screen. This is just to irritate you. We don't need this. This is fine. So I don't need ffmpeg anymore. You see the little icon on the file is a Notepad+ icon because I associated the files with Notepad+ because ta-da! In there is a data array, and this looks familiar to the one we saw in the source code. So you simply can copy this whole shebang, move it over there, and use this as an image. For me, this is the easiest way to get a graphics file onto an OLED display. Use the image editor of your choice. It could be GIMP, it could be PhotoPea, it could be Photoshop, it could be Affinity Photo, whatever you like. Save it as a BMP because BMPs are the easiest way to do here. ffmpeg, I think, can even convert Photoshop files, so it doesn't care about this. But BMPs is a flat file that doesn't have any bells and whistles, and the conversion there will always work. Try it if you like with other ones. And from there on, you simply use the command line that I put down in the video description for ffmpeg, so you know how to do this. You probably want to change the name of the array because image bits sounds a bit strange, so you can go for logo or whatever you like over here. This is simply normal C++. Copy this, paste it over to your code, and you're done. Back to the show. To make your life a bit easier, I left some instructions in the images.h file. You'll find this in the download. All right, back into our little software over here. That should be pretty easy because we simply have to use two I2C devices. That didn't work out. In the end, it came down to this. I use two I2C buses to run the whole show. Yeah, two, where only one is needed. This probably could be avoided if you use a ESP8266 on a different board that doesn't have the display on this. But with this one, this was the way I came up that did work. So I was going for a working software here, and I didn't care if it's beautiful or not. So let's go for this. Initializing the first I2C bus in UHG2 is pretty easy because I simply define my pins there. And over at the sensor.h, I declare different I2C pins, 12 and 13. The second I2C bus is invoked with this line over here. You have wire 1, this is the second I2C bus. So this is an instance of 2-wire, and we simply declare it this way. This is the address of the sensor. This is the include for the little library for the sensor to read. Over here, I tell the object of the library that I want to use the second I2C bus. Down in the init, I start wire 1 by adding the 2 pins over here. And one important thing I found out the hard way, this sensor doesn't like fast I2C buses. So I'm restricting the I2C bus over here to 100 kilohertz. From there on, everything is pretty much textbook. We simply check if the sensor is connected. When the sensor is connected, we start the sensor. Same over here in the display. Let's go for the init. Let me see. Init is over here. We initialize wire and UHG2 and set the draw color to 1 because of reasons. Well, you probably don't need this. I'll leave it in there. Next rabbit hole. Now you think, well, nothing can go wrong from here on. I simply get data because this is on a separate bus and everything will be fine. Wrong, young Padawan. Again, I found out the hard way that every time I want to switch the buses, using wire 1 over here, I need to initialize the bus first. So wire begin, set clock, every time. Well, it doesn't kill me, but I really would like to know why this is. I have to do this because otherwise the sensor simply doesn't work. By the way, I do the same over at display. We know that in the loop we have display dot draw display, so let's go over there, draw display. And what draw display does, it starts wire. We don't need a speed over here, but I need to initialize wire with the pins. Otherwise, no display. So after wrapping my head around all this stuff, I finally could get down to writing a program that reads the sensor and puts the sensor data on the display. Should we take a peek at this? Let's do this. Let's start with get sensor data. It's of course in sensor, and get sensor data is as easy as it gets. We simply tell the sensor, grab your current data and drop it into our structure over here. This is the commands for that. This is textbook. You could check out the example if you want to know more about this. I do some debugging over here. I simply drop this on the serial console so I have a clue what's going on in there. Right now our structure contains our data, so we can go for display and display, draw display. I print out the heartbeat here again. I have no clue why I did this, but well, we don't need this anymore. So again, UHG2 clears the buffer, and then I have a decision to make, because if the heartbeat is larger than 1, so there's probably something alive over there, I draw the data. Elsewhere, I draw the you dead yet. So let's have a peek how this is done. Start with the draw data. Draw data sets the font, sets the cursor, outputs the sensor heartbeat. Then it sets a smaller font, sets the cursor, puts out the O2 in the blood, sets the cursor, and simply draws the temperature. This is how should this be done. You guys remember the horror of the dot matrix display? Yeah, they should learn here. This is so much easier. If I don't draw the data because there is no heartbeat, so the sensor doesn't see anything, or the person has his finger on there is dead, I simply draw the you dead yet. So let's have a peek in this. This is even easier. I simply go for a bigger font, set the cursor to some coordinates that I found out by trial and error, and simply type you dead yet. This is all done inside the clear buffer, send buffer loop thing. So I clear the buffer and I send the buffer, and everything in between doesn't need to care about this. So this way I can simply tell, is there a finger on the little sensor or not? And from there on, I can write something that makes sense to the display. So was this fun to write? Yes, it was. Because I stumbled over so many things over here that I thought, well, this is unnecessary. But it kept me on my toes, so I learned something there, and I'm always grateful when I can learn something. The documentation by DFRobot is really good. The library looks fine, and it does exactly what it should. There are examples in there that tells you how to do this. UHG2 as a OLED library, perfect. This is always my go-to library when I do anything with OLEDs. LilyGo and the little display with this CPU on this, horrible failure. The documentation isn't there, and yeah, I didn't try the battery mode. Probably it will explode anyway, so maybe use something else. I had them laying around. You'll find the links to the hardware in the video description as always. So guys, this is it from me for this week. There probably won't be a video out next week because I have to do some photography. Yeah, this could be interesting too. And I'll be back in approximately 2 weeks, maybe earlier. So thank you for watching, and I hope you learned something as always. And, keep hacking.